Hi folks, today we're going to be working on some problems for beginners on functions and their graphs. So let's get started. Consider the function f of x equals 2x squared minus 3x plus 1. And we want to write the values f of negative 2, f of negative 1, f of 0, f of 1, and f of 2 in increasing order. In order to do that, we're going to need to evaluate the function at those values negative 2, negative 1, 0, 1, and 2 for x. We plug those in for the x. So in the first case, we'll begin with f of negative 2. Okay, so we need to plug in negative 2 for all the x values in our equation f of x. So what do we get? Well, we'll get 2 times the quantity negative 2 squared minus 3 times negative 2 plus 1. Once again, just notice we've replaced in negative 2 for the x values. Plugging that in, 2 times negative 2 squared is 8, and then minus 3 times negative 2, that will make a plus 6, and then plus 1. So 8 plus 6 plus 1, that equals 15. We can do the same process for f of negative 1. So f of negative 1, we're going to plug in negative 1 for all the x values. And all of a sudden, we get 2 times the quantity negative 1 squared minus 3 times the quantity negative 1 plus 1. And that should be 2 plus 3 plus 1, giving us 6. We need to do the same for 0, 1, and 2. Well, when we plug in 0, that's going to be the easiest one for us to plug in. Because notice those x values, anything times 0 will become 0. So notice we're just finished with 1 as our answer. And then we plug in 1, do the same thing, plug that in for x. You get 2 times the quantity 1 squared minus 3 times that quantity 1. So it's going to be 2 minus 3 plus 1. Well, that should be 0. And then last but not least, f of 2, when we plug that in, you get 2 times 2 squared minus 3 times 2 plus 1. So that'd be 8 minus 6 plus 1, which is equal to 3. Now we need to put these in increasing order. So you start with the smallest number, and then we build to the largest. So let's look at the values on the right-hand side here. So we have the smallest would be 0, then 1, then 3, then 6, then 15. So if we were writing those in increasing order, 0, 1, 3, 6, and 15. But notice the problem originally tells us f of negative 2, f of negative 1, f of 0. So we have to find all those associated values. Well, 0 corresponds to f of 1. So our first value would be f of 1. Our second value is 1, and that corresponds to f of 0. So we'd write f of 0. And then our third value, which is the number 3, is f of 2. Fourth value on that list is 6, which is f of negative 1. And finally, our fifth value, which is f of negative 2, is 15. Those two associate. So there's our list, and so to write it out, or equivalently, f of 1, f of 0, f of 2, f of negative 1, and f of negative 2 is our answer. Okay, so with this problem, a graph of the function f of x is given below. We want to evaluate f of negative 3, f of 0, f of 2, f of 4, and f of 7. So taking a look at this graph, where do we begin? We'll begin with f of negative 3. If you look, you need to go over to the x value, and then we could draw a vertical line to find where that vertical line intersects with the graph. That intersection point, we want to look for the y value. So let's take that line on over towards the y value. And notice when we have f of negative 3, we actually end up getting our answer being 5. Okay, because our y value is 5 at that location. For f of 0, notice we can draw a vertical line where x equals 0, finds where that intersects with the graph. Okay, so there's this point right here. And with that point, we want to look for the y value. Well, notice we've moved down 1 on the y-axis, so that would be negative 1. So f of 0 equals negative 1. For f of 2, once again, we draw a vertical line and find where that vertical line at x equals 2 intersects with our graph of f of x. So here's our intersection point, and looking for the y value at that intersection point. So we cross this over to the y-axis, and notice we've gone down 5 units. So f of 2 equals negative 5. And this is where you have to pay close attention to the tick marks over on that graph there. So pay particular attention to that. Moving forward, f of 4. So when we want f of 4, we draw the line x equals 4. That vertical line intersects with the graph at this location. We want to find the y value, so we'll cross that on over towards the y just so we can figure out what value that is. Notice that's 2 units up. So our answer is 2 because our y value corresponds to 2. And last but not least, we have f of 7. So we go where x equals 7, cross that over to the y-axis, and notice we get 1 as the coordinate. So obviously the coordinate 7, 1 would have a y value of 1, and so f of 7 actually equals 1 because each of these correspond to our y values. So moving forward, we have our next problem. Simplify f of 3 plus h if f of x equals 5x minus x squared. So this may look scary, and most people just think you toss an h on in the end. It's a little bit more difficult than that, but not too bad. And notice that we've replaced the x with 3 plus h. So we need to replace each x in our equation with 3 plus h. So you should have 5 times the quantity 3 plus h minus the quantity 3 plus h squared. So now it's just a matter of distributing and multiplying that value out. So we get 5 times that quantity 3 plus h becomes 15 plus 5h. And then when we square 3 plus h, just remember your product of squares, this would become 9 plus 6h plus h squared. Most people write 9 plus h squared, but remember that 6h, it goes 2 times the product of the terms that appear inside when you're squaring. So that's where the 6h comes from. Now, moving forward from here, what do we have? Well, we can distribute that negative sign to all those terms. And so you get 15 plus 5h minus 9 minus 6h minus h squared. And now let's do some regrouping. Regroup the constants together, regroup the terms that have an h together. And so you'd get something that looks like this: 15 minus 9, that quantity, plus 5h minus 6h, that quantity, and then minus h squared. So 15 minus 9 is 6. 5h minus 6h would be negative h. And so our final answer is 6 minus h squared. Or actually, if we wanted to simplify a bit more, make it look a little bit nicer, we can factor this one. You can't necessarily always factor, but in this case we can. So the multiples of 6, that would be negative h. Notice you have 2 and 3 would be kind of the values we're looking. And now, since it's negative h squared, we'll have a plus h and a minus h. It's just a matter of sorting those out. And so we get 3 plus h and then 2 minus h. And that would be another format for this final answer in terms of simplifying. Either answer would be acceptable, though. Okay. We want to determine if the graph of the equation below defines a function in terms of x. Looking at this graph, the main thing that we always try and use here is the vertical line test. The vertical line test, when we have a graph of an equation, that will tell us whether or not we have a function. So basically, we take this vertical line, and if it's hitting 1 or 0 points, then we're good. If it hits more than 1 point on the graph, then we've got a problem. So we'll start with this vertical line. We're going to slowly scan this thing across the whole graph. So watch as this vertical line progresses across, and notice that we have no points where it's hitting 2. So it seems like everything is hunky-dory and we're good. So notice that for any given x value, the vertical line is intersecting that graph at most 1 point. And it'd be okay if it was 0 because that just means that part isn't in the domain. So keep that in mind too. Some people worry about that. They see a graph that there's 0 intersection with the vertical line. That's fine because it just means that that value is not in the domain. But so what we have here is that this passes the vertical line test. So since it passes the vertical line test, what does that mean? Well, that means it's a function. It's that simple. So you just scan a vertical line across. If you're hitting more than 1 point, you know it fails the vertical line test, so it's not a function. And since we've scanned and it hits at most 1 point on every point on this graph, we're good to go, and we have that this is a function. Okay. We want to determine if the graph of this equation below defines a function in terms of x. So taking a look at this piece, we want to start with the vertical line from the left and move to the right and see if it hits the graph more than once. And if it does at any point, then we know that we have something that's not a function in terms of x. So if we start at the farthest most point on the left and start to slowly scan this across, notice there's no values, so we're fine there. But then all of a sudden, once we start to get to this circle, we start hitting values, multiple points, where there's 2 points intersecting with this vertical line. So you have 2 points on the graph. That tells us immediately, doesn't matter where it occurs, but as soon as we have 1, that says this is not a function in terms of x. So actually you can pick any x value between, what is that, -2 and 5 it looks like. Any x value between -2 and 5 is going to hit the graph in more than one place. So let's just pick x equals 2, for example. If you look at x equals 2, that intersects the graph, the vertical line intersects the graph with 2, 3, and 2, -5, meaning it fails the vertical line test because it's hitting 2 points. It didn't have to be those points. Those just turn out, that's an easy point. It's kind of the center of the circle. So, but any point in between here will do the job. Any point in between, I should clarify, -2 and 5. So what does that mean? It means we failed the vertical line test. So that means we do not have a function in terms of x.